This is an astronaut walking on the surface of the moon if the moon was underwater and at the bottom of a gigantic swimming pool. What you are seeing here is how NASA astronauts are training for their return to the moon, and it may look like fun, but this mission is a whole lot harder than you might think. The first thing that we need to establish about NASA's fake moon is that it is located at the bottom of a really big swimming pool inside the Johnson Space Center in Houston, Texas. The technical term for NASA's pool facility is the Neutral Buoyancy Laboratory. This thing is 202 feet long, 102 feet wide, and 40 feet deep, holding a volume of 6.2 million gallons. The water is just like any regular chlorinated pool water, and it's held at a temperature of around 86 degrees Fahrenheit or 30 degrees Celsius. Inside the pool is more than just a fake moon proxy, there's also a full mock-up of the International Space Station where NASA simulates microgravity spacewalks. On the surface of the pool is an Orion capsule that's used to rehearse water landings for when the crew finally returns from the moon. Water happens to be the best medium that we have on Earth to simulate the environment of outer space. This is something that NASA first started experimenting with back in the 1960s. The first Soviet and American spacewalks were performed in the year 1965, and scientists on both sides of the space race quickly discovered that maneuvering through a microgravity environment is a lot harder than anyone had been anticipating. This meant that astronauts needed to train themselves on Earth if they were ever going to be able to accomplish any meaningful activity in space. The same goes for walking on the moon, although there are some extra complications involved that we will explain in just a minute. The first thing that we need to know is that you can't just put a person in a space suit and throw them in a pool and expect that to work. The main reason being that the suit is inflated just like an inner tube, so it's going to float, which is bad. But we don't necessarily want the space suit to sink either. This is what's meant by neutral buoyancy. So, if we want to simulate the effect of zero gravity like what we would experience on an ISS spacewalk, then you need to weigh down the suit and the astronaut until they achieve a balance where they don't sink or float, they're neutral. This is achieved mostly by adding weights around the space suit, typically in the arms, legs, and torso, but sometimes they also use foam to strategically add buoyancy and achieve an even distribution across the suit. Now, if you want to simulate the environment of the moon, you don't want perfectly neutral buoyancy, which is 0 g, you want to get as close as possible to the effect of moon gravity, which is 1/6 of a g. This is where things get a bit tricky because you need to create a center of gravity for the astronaut that will be as close to a real mission as possible so that when they move from the pool to the actual moon, they won't be disoriented by their own weight. But since right now we are still inside a pool underwater, the astronaut also has a center of buoyancy in addition to a center of gravity, and the two will conflict with each other if they are not balanced out properly. What people need to remember is that walking on the moon is not easier than walking on Earth just because the moon has lower gravity. It's actually much more difficult to walk on the moon. That's why so many of the Apollo astronauts fell down so much. The trick to understanding this is straightening out the difference between weight, mass, and inertia. When you go to the moon, your weight on a scale will read at 1/6 the number you'd see on Earth, but that doesn't change the physical mass of your body. All of the material, muscle, blood, and bone, of your body still has the same amount of mass no matter where you are in the universe, and that means your inertia also remains the same. In really simple terms, inertia is your body's tendency to resist a change in velocity. So, the energy you have to exert to get yourself into a sprint and then, conversely, the energy that you need to slow back down again, that is working against inertia, and you still need to exert that same amount of energy on the moon as you do on Earth. Making things even more tricky is that on Earth, your weight helps you to gain traction against the ground to push your mass in a new direction. So, with so much less gravity on the moon, you have that much less traction but again require the same force of inertia. The result is a tendency to lean too far forward when trying to get the body into motion. Then you have your foot slip and lose traction. Hopefully, that helps to explain why all of these astronauts spent so much of their time on the moon falling down, and why NASA is already hard at work preparing the next crop of lunar explorers to deal with the challenges of mobility that they're going to face up there. Because the thing that really sets Artemis apart from Apollo is the length of time spent on the moon. People will be up there for a week at a time, doing moonwalks pretty much every day. They need to learn to be mobile for long periods without getting exhausted and without causing excessive damage to their equipment by falling down too much. So, the first thing that our lunar explorers will need to do is load up into their spacesuits. NASA has been using a design of their XEMU or Exploration Extravehicular Mobility Unit. These are much different from the EVA suits used for spacewalks on the ISS. The current version of the suit was designed and manufactured for NASA by a private company called Axiom Space, and NASA has been using the Axiom lunar suit for neutral buoyancy lab testing since January of 2024. The internal pressure of the suit is going to be somewhere between 4 and 6 psi. NASA is still experimenting to try and find the ideal number. The goal is to balance atmosphere with flexibility because the ambient pressure on Earth is around 14 psi, but if you inflated the space suit to the same level, it would get too rigid and the astronaut wouldn't be able to move freely. But if the pressure dips too low in a vacuum environment like the moon, then the astronaut will die, so it's all about finding the right balance. Pressure is also a factor when doing moonwalks underwater. The astronauts are going to spend 6 hours underneath 40 feet of water, which has the potential to cause decompression sickness, also known as the bends, which is a result of excess nitrogen being absorbed into the blood at higher pressures and then escaping back out at lower pressures, causing bubbles to gather around joints, the spinal cord, and the brain. NASA combats the bends by giving the astronauts a special blend of air that has a higher concentration of oxygen and a lower level of nitrogen compared to regular air, which is 78% nitrogen and 21% oxygen. What the astronauts are breathing underwater is more like 46% oxygen, which allows them to spend as much time on the bottom as they want and then return to the surface without having to come up slowly like a scuba diver. With all of that said, the astronauts are going to be lowered down into a low-fidelity mock-up of the SpaceX Starship human landing system. It's basically just a big 9 m diameter circle that has a simulated airlock for the astronauts to emerge from. Then they walk over to a simulated elevator platform. The real Starship will have to lower them 30 feet to the surface of the moon, but in the pool, they just walk straight out and down a ramp. The surface of the moon is built out with simulated rock structures, and the ground is covered in a type of sand that replicates the lunar regolith or moon dust. Once the astronauts are out there, they're going to work at performing the same tasks that are going to be done on the Artemis 3 mission. They push a hand cart along that's full of tools for collecting samples from the ground, picking up rocks, chipping away at boulders, and digging into the lunar soil. The astronauts are also going to practice technical maintenance activities like detaching and reattaching hoses. And for one final bit of authenticity, NASA has recreated the lighting that astronauts will be working in at the south pole of the moon, which is not going to be like any other moonwalk that we've seen before. If you look at all of the Apollo landing locations, they are right around the lunar equator and were conducted in the middle of the lunar day, so we are getting a lot of direct exposure to the sun. Down around the South Pole region, though, things will get a lot more dramatic. The sun only comes in from a very low angle that sits just above the horizon, like what we'd see very early or very late in the day. The result is going to be extremely long and dark shadows. To prepare astronauts for these challenging lighting conditions, NASA has been working on a new lunar lighting simulator at the bottom of the 40 feet deep pool. Achieving this look involved turning off all the lights in the facility, installing black curtains on the pool walls to minimize reflections, and using a powerful underwater cinematic lamp to get the conditions just right. Unfortunately, we don't have a lot of images to show of this yet, but this should help to give you a better idea of what video from the Artemis missions is going to look like. It will be a lot different from the classic Apollo images and much more dramatic. Artemis will also be investigating the floors of ancient craters on the moon that have never been exposed to sunlight at all, so that's another variable that NASA will need to begin training their astronauts to deal with. And this is where it's all going to happen, on a fake moon at the bottom of a giant pool. Now you know.